Hi there and welcome. In this video we will explore various conditions that allow us to fetch data using DBIx. To note, we will look at base constructors using simple where SQL conditions. In the next video we will dig deeper to see how to construct multiple conditionals to produce more complex queries. But for now, let's explore the basics. With that said, let's get started. So in the previous videos we looked at how we can connect to schema, and we also explored what is schema, ResultSet, and result. Before we start selecting results, let's just clean this up a little bit and let's extract us connecting to the schema in a new package. So I'm going to go to lib folder and create a new file, and I'm going to call this connection.pm. So let's name it package, connection, use strict, use warnings, standard pragmas that we use. Now let's introduce a new subroutine called sub connect. And there we're going to have a class method, so my class, and we just get arguments on that, which is going to be our class name. As you already know, that's what we get on the class methods. And I'm just going to paste what we copied from the script file. Let's align this a little bit better, and let's see what we're missing. We need to use the my schema app. So that's actually schema my app, so use schema my app. And looks like everything else we can leave it as it is. And at the end, I'm just going to return schema. Alright, and since this is a Perl module file, we need to return a truthy value. So let's check if everything looks good. So getting schema my app, we're connecting to it. We don't have any other dependency. Alright, so let's test if this is working now. So instead of requiring the schema, we can just require the connection. And here, let's replace the schema with connection, arrow annotation, and a connect method that we introduced. I think I called this connect, so let's check this again. Yes, so that's called connect. Alright, and if we rerun the script, it should do exactly what it did before. So Perl breeze and run the script.pl. So that looks good. We're dumping out the object, which is the result node. Now one more thing before querying the actual data. I just want to know that whenever we access the result set, as we do here with the result set node, we're not actually invoking the query. We're only invoking a query where we're doing methods such as first. There are other methods like when you call all to get all results, or single. I'm going to copy this part and replace that where we're dumping it from the dumper method. Save this up, go to the console, and from the previous lecture we know that we can debug our queries by adding debug trace equals 1. So if we rerun this, we're going to see that we are dumping out the query that's being run. So if I remove the first part and just do results at node, rerun the script, you're going to see that nothing happens. So as I said, you need to call methods such as first, or all, or single, or find. Now as the next step, let's start to actual query the data and explore what do all of these methods that we can call on the result set actually do. Starting with the all method. Now all, as the name implies, returns all the results. And these results are going to be our result object. So if I say my array, which I'm going to call all, and assign the result from schema result set node all to it, we're going to see that if we do something like print scalar, so scalar, and convert the list context to scalar context, which is going to give us the number of items in that list, just add a new line at the end, print this out. Oops, so that's not scalar, that's actually our all list that we just introduced here. So rerun the script, we're going to see that we have 6 items. And as we already know, we can actually use a feature called say that's just going to append the new line at the end. So use feature, quote word say, and let's do that. And we can just do say, scalar, and print this out again, and we're going to see 6. Right, so we know that all method returns all the results. But that's not really useful in a sense if you have hundreds of records that you want to query for. The question becomes, how can we provide conditions, the SQL conditions, how we would like to query our data? For that, we can use search result set. Now search result set accepts 2 parameters. First parameter, specified as a hash reference, you can provide your conditionals, where you can say, for example, if you look at the database where you have the nodes, you could say return me nodes where the description equals node 1 from user 1, or return me a node where user ID equals 1, and so on. And for all the conditions that match, you can call the method all, which is going to, of course, return the filtered result based on your where conditions. Now the second parameter is for conditions such as applying grouping or specifying how many rows you want to return from your result set, and similar filter conditions. But we're not going to look at this now in the current video. We're going to have a dedicated video for that later on. So starting with applying the where conditions, how you can do that is actually quite simple. The first thing you want to do, you want to specify a column name that you would like to filter on. For example, you could say, I would like all the nodes where user ID equals to a specific value. In this case, if you look at what we have in the database, we have 2 user IDs. So 6 nodes, and 3 nodes are from user ID 1, and the other 3 are from user ID 2. So we could say, give me all the nodes where user ID equals 2. Now if we do that and rerun our script, actually nothing's going to happen because we are not calling a method to invoke the result set such as all. So if we add that, save the script, rerun it, we're going to see that we're getting back 3 results. And just to make this more explicit, I can say got number of results and concatenate that with scalar context of the list. We run a query where we're selecting all the columns from nodes, and here you can see is the where condition that we applied, where we said return me all the items where user ID equals question mark, which is going to be placeholder, and the value for the placeholder is 2, and we got back 3 results. And if you look at the database, those results should be the last 3 ones that we see here. So nodes with ID 4, 5, 6. You can also do an opposite condition, such as where you say return me all the nodes where the user ID is not equal to 2. For that, instead of providing the value you want to filter on, you need to extend the conditions with additional hashref, where you can provide a string saying not equals to arrow notation 2. So this says return me all the nodes where user ID is not equal to integer 2. If we run this and look at the query, this is exactly what we expected. So give me all the results from nodes where user ID is not equal to 2. And with this format, you can extend this even further, such as saying you would like to apply a like condition. And like is going to accept a string pattern where you can say, give me a partial string that matches beginning or the end of the string if you're using percentage signs or underscore for one character. So here we could say, instead of user ID, we can say description like percentage signs where it says match anything before in the string and match anything after in the string. And let's say we're searching for something like from user to, so we can add that to our search pattern. So from user to, save this, run the query. We're going to see that we're getting 3 results, and the query looks like where description like and the value that we're looking for from user to, so getting back 3 results. Now if you would like to say give me items where not like description pattern, you can prefix it with not underscore and then the like keyword. If you run the script, we're going to see that now we are looking for results where description not like the given pattern. And again, we're getting back 3 results. You can also provide conditions such as in, where you would, for example, like to search for all the items where, if we go back to using user ID, inside a list of 2. So this is going to translate to select all from node where user ID in number 2. If you run this, look at the query, it's going to say where user ID equals number 2. So this is going to put one placeholder and replace it with number 2. Now we can of course extend this like 3 or 4. We're getting back 3 results still, but now we have 3 placeholders for a supplied values 2, 3, 4 that we can see here, 2, 3, 4. And since we have 1 result matching for user ID 2, we're getting back 3 results. So we know that other 3 nodes are for user ID 1. Very similar to like, we can say where user ID not in 2, 3, 4, and that's going to translate to SQL user ID literal not in given IDs, and you can get very creative with this, as you can see. Now you can also look for conditions such as give me all the items where a specific column is not null. So in order to do that, you can say user ID not equal to, and the value is undef, and undef is going to be automatically translated to null. If we run this, we're going to see that we're getting back 6 results. So in the query, we're saying, give me all the items where user ID is not null. And we know that none of the nodes have user ID null, so we have 6 items returned. Or if we inverse this and say where user ID is null, of course we're going to get back 0 results, because if you look at the database, we have no entries in a node table where the user ID equals null. All of these nodes have ID 1 or 2. And you're not, of course, limited to only one field. You can extend this even further. You could say where user ID is not equal to null, and then add another column such as description, like, as we saw before. So like keyword, and then we provide a pattern where we say from user1. Save this, run the script. We're going to see that we get 3 results, and in the where condition we can see that our 2 conditions have been applied. So we're saying description like question mark, which is going to be the placeholder where we add the value, and the user ID is not null. And these again are the values that we're feeding to these placeholders. Well, we have only one placeholder for description, so that's why there's only one question mark. Now at this point, you might be wondering, how can we supply multiple user ID conditions, such as I would like to get all the results where user ID, let's say, is not equal 1 or 2. For that, we would of course need 2 conditions to provide in the search result set. So we could build out from 2 definitions saying that, let's say, user ID is not equal 1 or user ID equals 2. But at the same time, we know since we're providing a hash reference, then all the keys are unique. So that means the latest key that we're providing in the hash reference is going to overwrite all the previous keys with the same name. Now don't worry about this now. In the next videos, we're going to look at how we can extend these conditions even further and supply a structure that's going to build more complicated queries using and or keywords. But for now, know that if you provide a single column names which are unique, you can easily apply filter conditions such as we see here. So I'm just going to remove the duplicate user ID. Now this is all good and pretty straightforward. You might have more complicated scenarios. For example, you want to use MySQL functions such as length to check for returning all the items where length of a field is specific size, such as description. So let's say we want to return all the nodes where description is longer than 2 characters. Now for that, if I just remove the user ID, how we approach that is, instead of providing the column name as the key, we want to provide a string where we wrap the column that we want to apply MySQL function to and say, for example, length of description, arrow notation. Then we extend this with a hash reference where we provide 2 things. First one is going to be the operator that needs to be used to compare the size of the length. Here we can say where the length is larger than or equal to and the size of the length, where we can say 2 characters. If we save this, run the query, we're going to see that now our query looks like where length of description, which is going to return the length of all the description fields that we have here, is larger than 2 characters. And we're getting back 6 rows because all the description fields, if we check in the database, have a description which is larger of 6 characters. Now that's one way how you can apply MySQL functions. But what if you wanted to build a query that uses regular expression to search for specific description parts? Let's try to do that. Now let's say we want to use REGEXP function where you can supply a pattern to look into a specific field. So what we can do, we can say description, arrow notation, hashref format again, where the first value is going to be the condition we want to apply for the field that we're filtering on. So here we want to apply the regular expression and then we provide a value. For example, we can say from user2. If you run the script, we're going to see that the query that we got is saying, give me all the nodes where we apply the regular expression function from user2 yields 3 results. And that looks correct because we have 6 nodes and only 3 of them have user2. So that's pretty much it about building basic where conditions. Of course, there's more conditions you can apply. There's more functions you can use. But the key point here is that we want to know how to apply the structure, and now we do. If you want to search for specific values on a field, you can use simple expressions such as where description equals, let's say, number 3 or so on. Or if you would like to extend these with functions, you can use the hashref notation where you provide the filtering condition such as larger than or equal and then the value that you want to apply it to. And from there, you can build more complicated queries. Now, as I said before, there are actually a couple of functions that we can apply to filter down the results. And all is probably going to be the most used one because you want to apply the conditions and then you want to get back all the rows. But there are other functions such as first and single, single and find. So let's look at what these do. I'm going to comment out everything what we have here and go one by one. Right, so we know what already all does. We just called it, so it just returns all the results. Now the second one is going to build all the result sets behind the scenes, but it's always only going to fetch the first one, what is at the top of the result set. If I rerun this now, we're going to see that we got only one result. Well, this is also probably because we're applying a condition on the description that says, tell me where description is larger than or equal to 3. But if we say, give me a description like the body where it says note and rerun this, we're going to see that we're still getting back only one item. And again, we build our result set, we construct all the rows under that result set. We are only getting the first item from all of the result sets. And it can be a convenient method if you know you have many results, but you only want the first one, and this is definitely something you can do. Now let's look at the single one. The single one is a little bit more different than first. It does try to achieve the same thing as the first method, but the purpose of it is different. When you call single, you must guarantee that the results that you're getting back on your result set is always going to return only one result. If your result set returns more than one result, you're going to get a warning that says if your result set returns more than one row and you're calling single method, then something is definitely wrong. Because single expects one and only item returned. And it's much more efficient than calling first, because single doesn't do a full-blown construction of your result set. It's going to discard everything else in your result set and only construct one single result. And if there's more results returned by your result set, then something is not right. So let's try to run this. And here we can see that the warning is produced where the query is returning more than one row. So as I said before, single method should be used only when we know we're getting back one result. Now in this scenario, we're going to get back all the results because we want a description where the content of the node contains a keyword note. All of our nodes contain a keyword of note. And since this is not case sensitive, then capital note also counts as for the pattern just note. So how can we impose this single query context? What you can do, you can provide these where conditions on a single method where you can filter down results to guarantee uniqueness of your result. Note here that I said that search results takes additional second argument where you can provide your rows and limit your results. Single method does not do that. You can only provide your search conditions. So for example, you can say, give me all the results where user ID equals 2. But of course, this is not going to be unique anyway, because we have 3 nodes with user ID 2. So in that case, we can use gimme item where ID equals 1. If we run this, we're going to see that we're getting back one result. And the condition that we applied is description like note. And here you can see that we have additional extended query pattern from the single method, which says gimme an item where ID equals 1. So we now know what the single method does. Let's look at the find. If I uncomment that, and find is pretty much the same thing what the single is. And actually single is the engine behind the find method. So when we call the find, the single method is called behind the scenes. So naturally we can also extend the find method with parameters such as find me a record where user, well, not a user ID, but ID equals 2. If you run this, it's going to apply the same condition as the single method. The difference here is that for find, we can also provide a unique constraint directly on the method argument. So we can say, find me the node where ID equals 6. If I run this, I'm getting back one result. And here we can see the same condition was applied, where it says where description equals like, and then for me, ID equals 6. So you don't need to use hashref format to extend those unique conditions. Now the key difference between single and find is that on find you can actually use 2 extra arguments. The first one, you can filter down for key and value that you would like to find using unique constraint. And the second parameter accepts a unique key constraint that you can filter on your results. Now by default it's going to use the primary key, so you can filter on IDs like from 1 to 6 to find specific node. But what if we didn't want to use the primary key, but we wanted to use another unique constraint? Now this is where the second argument comes into play. If we provide key and the unique constraint, we can specify which unique field we can query using the given value. Now currently there's a small problem. We don't have any unique constraints apart from the primary key. So let's change that. Just look at how this works. If we go to our SQL editor, we can add a unique constraint. And we can do that by saying alter table, which is our node table, and add constraint. So we want to alter our nodes table, add a constraint with a name that we can choose as we please. I'm going to say unique, UNQ, node, that's our table name, description, and then we can provide unique keyword that accepts on which field we want to add unique constraint. I'm going to choose the description field. If you run this, this looks good and it didn't fail because currently in our nodes table, all the descriptions are unique. So if we check the results here now, SQL, so let's just click OK. We can run show create table node. And now we can see that we have a unique constraint, which is unique node description that we added on the description field. So once we're done with this, we're just going to drop the unique constraint. Alright, so if we go back to our editor and supply the key name, which is unique node description, and here we say if you want to look for description, which is exactly the value that we have unique constraint on. So here I'm just going to copy the description from node number 2, paste that in, save it, run the script, and we're going to have an error. And that makes sense because we're saying that there's supposed to be unique constraint on the node table with this name. But if you look at our schemas, my app result node, we're going to see that there are no unique constraints. And if we think about it, we modified the database, but we didn't modify our schemas. And this is a great example where it shows that we actually need to regenerate our schemas once we supplied new constraints on a table, because of course our schema is going to change. They're not in line with what we have in a database. So the query is not even going to be ran. So how we can do that, since we conveniently have the dump script, all we need to do, we just need to rerun this. We can say Perl dump.pl, that's run fine. If we check the nodes table, something that says unique, here we go. We have our unique node description, and it adds unique constraint on our node result with the name that we chose. Now, if we go back to our script, so rerun the lib script, we're getting back one result. And that looks good. Let's just dump this out. So dbig trace equals 1. And what we got is that we're saying, give me description like, and description equals exactly to the node 2 from user 1. So this all looks good. Now before we move on, let's do one thing. As I said, we don't want unique constraint on our description field. In order to drop that, we can say drop index. We need to provide our index name, which was unique node description on table name, which is our node. Run this, and looks like this executed fine. If we check the node table, let's run the query that says show create table node. We're going to see that we don't have our unique index. As you might figure, that we actually now need to regenerate our schemas again, because now in our schemas we said that we have a unique constraint, which is not really the case. So if we run the script, which is Perl dump, and regenerate the schemas, check the nodes for unique constraint, we don't have it anymore, so that looks good. Alright, so we looked at all first and single methods and also the find method. Now one more final thing I want to touch on is there are going to be scenarios where you might have hundreds of thousands of rows in your database. And if you call methods such as all to read them in your list, these are going to be kept in your memory, right? So you might have even large tables and you're selecting all the columns. And when you're selecting potentially thousands of items in the memory, that's going to cause issues. So what if you want to still query potentially thousands of items, but you want to do it one by one by not putting everything in the memory in one go? So for that, we can create a cursor, and it's going to allow us to go in a loop for each record and do whatever we want to do with that result item. So how we can do that? We can say that I would like to keep this query, store this in ResultSet variable. We say description like node, so that's fine. I'm going to remove all of this, which is after search result set. So we have only the result set itself. I'm going to comment out this debug line just to rerun the script again to make sure the query is not being run. Of course it isn't, because we're not invoking our result set. We only have a reference to our result set in this variable. So now I will introduce a while loop where I'm going to say while my result equal result set that we constructed above over here, and we're going to call the next method. Do that, and I'm going to say result ID. All right, if you run the script, we're going to see that we printed for every time when the loop run ID 1, 2, 3, 4, 5, and well, up to 6. Now, of course, we don't have a lot of data, so this is not very useful. But again, if you have hundreds of thousands and you want to go through them one by one, this is much more efficient than loading everything in your memory using methods such as all. Alright, so that's it for this video. We looked at how we can query the data through various where conditionals, and we also looked at methods you can call on ResultSet to get only one item or all the items. And finally, we looked at how we can query results in a loop without loading everything in a memory. I hope you found this video useful, and I'll see you at the next one.